Thank you, Julianne. Welcome to the non-coffee ILR session this afternoon. So this is my normal nap time, and I was looking for some coffee. So
I'm going to find you some.
the lines or the lights are down. So if you want to start your nap now, that's fine. This is my normal nap time. Today we're going to talk about Admiral Rickover and his nuclear navy, and I'm going to give you some information. But he was a well-known man in the Navy, and the worst message you could get was Admiral Rickover is coming to visit. And there was a rig for Rickover Bill. He would always ride the nuclear submarines on their first trip, and he would come and stay on the living barge. And the living barge room where he would sleep had to be light proof, so you had to go in there and turn off all the lights in that stateroom, turn all the lights on everywhere else, and then put tape over everything where the light leaked in. And he liked to have a barber nearby, and he liked to have seedless grapes. If you couldn't get any, there was a young seaman who was designated to put the seeds out of the grapes that we were going to give him. And there had to be S&H lemon drops handy. And if he came onto the living barge and the person who was there standing by the door would say, "Attention on deck," he would get really angry. So it was an interesting time. He had nicknames sort of like KOG, for the kindly old gentleman. My first submarine commanding officer went down for an interview, and the only time he ever swore was when he talked about Rickover, and he would say, "That's so be," you know. That was the only time he swore. Okay, let's get started here. We have a lot to do, and because then I want to get into sea stories and lies and what have you. Who knows? Oh, there we go. Okay, I want to tell you about Rickover because he was a very interesting, and I think I have it. Yep. Okay. He was born in Russian-occupied Poland. That area of Poland was sometimes Russian, sometimes German, sometimes Polish, sometimes Austro-Hungarian. So he was born at the time Chaim Godalia Rickover in Russian Poland. He immigrated with his family in 1905 to the USA with his mother. The father had come over earlier, and they joined him in Chicago. He went to John Marshall High School, graduated with honors. He went to the Naval Academy. He was 107 out of 540 in the Naval Academy. Now, there's a rumor, you see on the right, some blue arrows pointing to a page where he had his picture on it, and he was very unliked by his classmates. He was probably the only Jew at the academy at the time, and his page has perforations, so if people didn't like it, they could rip it out. But that does not seem to be true, because the one on the left is also him and his discussion there. And it is not on a perforated page, so you could not get rid of all about Rickover with that perforated page if it's really true. He was on the little destroyer there, the Lavalette, and then he was on the battleship Nevada. But look at the destroyer, you see a blue arrow pointing down. There's a little gun on a little ship, and keep thinking about that. In 1930, he got his Master of Science in EE at Columbia. And then later he was qualified in submarines, qualified for submarines. And again, you have a little gun on a little ship on each one of these submarines. And I'll talk about that more later. He translated Das Unterseeboot from German to English in 1933. He was CO of a minesweeper, and I don't see a gun on that one. And it may be because the minesweepers were worried about magnetic mines. And if you had a great big steel gun on your deck up there somewhere, you weren't very anti-magnetic. Okay. In 1937, he was promoted to lieutenant commander and became an engineering duty officer, which meant he was no longer eligible for command of ships at sea and would be assigned to shipyards and the Bureau of Ships and so forth. He was assigned to the Cavite Naval Shipyard in 37, which is in the Philippines. It's a ship repair facility, I think, instead of a naval shipyard. And ships in the Pacific could come to Cavite for mid-level repairs that couldn't be done at sea, but not full overhauls. He became assistant chief of the electrical division in BUENG, the Bureau of Engineering at the time. The names keep changing. It was BUENG, BU ships, NAV ships. I don't know what the name is now, but same thing. He reviewed the World War I technical manuals, all of the contracts that he had for electrical stuff, and he rewrote all of them and updated them, and he became a fierce program manager for electrical installations throughout the war on all the Navy ships. And he invented a mechanism that would go in our great big electrical switchgear, which are about as big as I am or bigger. And what would happen was when they fired the big guns on the battleships or when there were mines nearby or explosions, the rattling of the electrical gear would cause the electrical circuit breakers to trip open. And he invented a mechanism that would, if it felt an explosion, there was some kind of a mechanism that would kind of be flipped up and it would prevent the circuit breaker from opening, but then it would drop back down and it would perform its safety function. In 1942, they sent him out to Hawaii after Pearl Harbor to supervise the electrical repairs on the California, which is not doing so well in the photo on the right. In January 42, he was promoted to commander and then temporary captain. And during the war, people got promoted unbelievably rapidly. And so he was a temporary captain. And they assigned him in 45 a ship repair facility, Okinawa, but it was destroyed by a typhoon. And Carol's father was on a troop transport in that same typhoon or another one in the Pacific about that time. He became head of the electrical section of BU Ships. They changed the name from BUENG to BU Ships. In 1945, also, Oak Ridge was assigned the task to develop nuclear electrical plant. So that was all the Oak Ridge engineering activity. And he got himself assigned down there in Oak Ridge in 1946. He wasn't assigned as the officer in charge, but he acted like he was assigned as the officer in charge. So he required the reports from all the classes that everyone was taking, the civilian engineers as well as the naval officers, every week to make a report so everybody could keep up at the same level of their education about nuclear power and a nuclear power plant. In 47, he was back in DC in the Bureau of Ships. And at the same time, Fleet Admiral Nimitz came to Washington to be the chief of naval operations. He was a submariner in the Pacific, and apparently they may have known each other by some kind of paths being crossed. But he was able to convince Nimitz that we needed a nuclear-powered submarine. He shepherded a memo from CNO to SECNAV to AEC to support joint development of nuclear reactors for Navy ships. It didn't say Navy submarines because he wanted the rest of the admirals to come on board with nuclear power, although it was going to be submarines. He approved zirconium, which was a metal for the cladding of the fuel rods. And he was head of both BUSHIP's Nuclear Power Division and the Atomic Energy Commission Division of Naval Reactors Development. So let me just show you this. You see the blue arrows there. They point to his jobs. On the left is Naval Reactors Branch of the Atomic Energy Commission, reporting to Division of Reactor Development, directly down from the AEC General Manager. On the right-hand side, you see the Navy Bureau of Ships. He was Assistant Chief for Ships, he reported to, and under that, he was the Nuclear Power Code 490. And you can see that he had, let me see if the laser is working, he had some direct connection with Electric Boat Shipyard that built a lot of the submarines in World War II. And on the left, he had a direct connection all the way down through the Schenectady operations, Chicago operations, Pittsburgh, Bettis Lab, and we'll go into these things. And so he was double-hatted, and he went by the golden rule. He who has the gold makes the rules. So he controlled AEC and USN dollars. He hired and fired managers, which he probably wasn't allowed to do, for General Electric, for their nuclear people, for Westinghouse, for their nuclear people. He selected General Electric and Westinghouse, and then he put the heat to them to make sure they did what he wanted them to do. He worked the Atomic Energy Commission against the U.S. Navy and the U.S. Navy against the Atomic Energy Commission, and we'll have some more discussion about that later. He personally selected all naval officers that were in his program from the beginning. And by the time he was retired, he had probably interviewed 40,000 officers. And Will was telling me the current director of Naval Reactions has interviewed, 40,000 himself. So they're probably personal interviews of naval officers in the order of 100,000 since the program began. So what does that mean? To be selected for nuclear power, you have a Rickover interview. You have an initial briefing. When I was called up in February of 1964 for my interview, along with my good friend Charlie McVeigh, we were both Burke scholars getting PhDs in nuclear energy at Cornell at the time. We went down, and the first meeting is with the Bureau of Personnel, because they told us, look, if you have a bad interview, don't write your congressman directly. Come and talk to us, and we'll try to smooth it over, because this was a selection process. If Rickover didn't select you, you were back to the fleet, doing whatever you were doing before. So there's 3 to 5 or 6 preliminary interviews. My interviews, one was the director of reactor engineering, and we talked about my dissertation topic. Another guy was a director of chemistry. He had been to Cornell. We talked about changes in Cornell since he was there. Another one was a naval commander who later became my commanding officer. We talked about the officers that were at the Naval Academy when we were both assigned there. And there's probably 1 or 2 others, but for me, it was just chit chat with these guys. For a lot of other people, it was hell on wheels. And then you got the interview. So at that point, you were called over to, in that days, it was the old Navy building downtown Washington on the mall, the old World War I temporary buildings that had been there for a long time. You were introduced to a naval officer who was your guidance. He was actually the witness to what happened when you went to see Rickover. So if you had a big complaint about Rickover, there was a senior naval officer who was there, and he saw the whole thing. So then you'll get invited into Rickover's office. It was an old beat up Navy standard metal desk piled high with papers. and he was sitting off to one side, perpendicular to me. I don't think he ever looked at me. He had a folder there, which may or may not have had anything to do with me. And my entire interview was, "You married when?" "No, sir, that's all." So that was my interview. But he could say that he had interviewed and selected me. And the rumor was that was to protect us from Congress. So if we had screwed up, he could go to Congress and say, "I personally selected that man. Are you questioning my judgment?" That may or may not be true either. One other interview I'll tell you about, and then I have a book here, Down Deep, which Don McLaughlin has read, and every time I pick it up and read, I learn more things. This is about Charlie McVane, the other naval officer I was telling you about. It's excellent reading. Charlie was called in, and he was a surface officer. Burke program scholars were sent to sea for a year to get qualified at sea, and then we could pick our university and go get a PhD in anything technical, physics, or math. And so Charlie had been a surface officer, and his CO had cycled him through everything, so he learned about the Navy. And then when he went in for his interview with Rickover, the whole interview was in the book there, but basically he did not want to come here to be a nuclear engineer. So he told Rickover, he said, I need to go back. I've been 1 year at sea, 4 years in school. If I join your program, I have another year and a half of school before I ever get to another ship. I want to go back and do my job as a naval officer. And Rickover was basically shaking his head saying no. And he said, "Well, what are my options?" Rickover said, "None." He said, "Then God damn it, I'm a volunteer." And the other one was when I went to nuclear power school, the land classes, the guy who graduated first by the way, Charlie graduated first in every course he ever took. This guy had graduated first at the Naval Academy. He was an ensign in my class at the school in Mare Island. And he had not gone to the first series of interviews that midshipmen were called down to Washington for their interview with Rickover. And he later decided that he did want to be a nuclear engineer. So he asked permission to go down to Rickover's office and get the interview. And when he got into Rickover's office, Rickover said, "Who the hell do you think you are, just signing up and making an appointment to come down here, and you didn't come on the original time? Get out!" So this ensign left, and he slammed the door and broke the glass in the old man's door. But he was selected. Water, thank you. So, but he was selected. So the interviews were famous throughout the fleet. Then the classroom training, what did we do? 6 months. We studied nuclear fission, fluid dynamics, fuel element theory and design, heat transfer, mathematics, including the differential equations for neutron distribution. That was the only math test I got a 0 on. It said, describe the nuclear flux in a rectangular reactor. So I wrote down the answer. I didn't, because I'd been doing that for 4 years. So I knew what the answer was. It's a cosine function. And so I hadn't read the other little part that said, show all work. And so the guy put a 0 because I didn't show any work. I told him, I didn't do any work. I know the answer. 0. Okay, we studied radiological theory and chemistry. Then we went to a nuclear prototype for 6 months for training. And the first thing you did was go to some more class and learn about that particular prototype. In my case, I went to the D1G, which is a GE-designed destroyer nuclear power plant, which was very well designed. I liked the plant, nice. And then we had to go in the machinery design and operation of every piece of equipment that was in that reactor and engineering spaces. And I just loved it. I enjoyed playing with all the machines and everything, but we had to learn how to open the steam stops and bring steam into the engine room and operate every machinery and learn how to start up the steam-powered main feed pump, learn how the generators worked, how everything was connected together, and all of that part. Then there's engineering officer of the watch training. In addition to that, all the enlisted guys had to do all that stuff on all the machinery also, particularly the kind of machines they would be operating. So the engineering officer of the watch training, we had to learn how to start up the reactor, bring it up to power, bring steam in the engine room, start all the equipment, and get everything operating. And then there was an oral exam. After the oral exam, you were given a white web belt instead of your khaki belt. And that identified who had been qualified as engineering officer of the watch on that particular reactor. So they could tell whether you were a newbie or a qualified guy. Okay. Then we got ship assignments. So that was a little diversion there. Rickover, controversial, of course. Hyperactive, politically blunt, flamboyant, and he was a workaholic. I think he slept maybe 3 or 4 hours a night. He always demanding of others without regard to their rank or position. I mean, he would have a Navy captain come in to try to be the prospective commanding officer of an aircraft carrier. So this is a fairly senior guy, and he would throw him out of the office too if he didn't like him. Okay, little tolerance for mediocrity, none for stupidity. Hated the bureaucracy, but he was an expert at manipulating it. And we'll see some of that in the next to last lecture when we talk about civilian power plants. If a person was dumb, Rickover thought he should be dead. Okay, he established the Bettis Atomic Power Lab with Westinghouse near Pittsburgh. None of that existed until he got into Westinghouse. And these Westinghouse and GE were kind of in a slump after the war because they weren't building all of these turbines and steam equipment for ships because they weren't building any ships. So Westinghouse was absolutely delighted to have Rickover come in and beat him over the head because it meant jobs. So, and he made the unilateral decisions on who was going to do what. So he liked the way Westinghouse was working. That meant they were listening to what he told them to do and doing it. He assigned them to design the reactor for the submarine and to build the prototype and the nuclear reactor for Nautilus simultaneously. Now, this is unheard of in nuclear or any kind of other engineering development of any kind of a project in the whole country. You don't build them simultaneously. This is Electric Boat on the right down there, and the diagonal dock is a dry dock and looks like it has a submarine in it. The covered building on the left is a shipbuilding ways. That's where you build ships before you slide them into the ocean. But Electric Boat was tasked with building wooden and cardboard mock-ups of the entire engineering spaces, the reactor, the pumps, the steam equipment, and everything in a 28 to 32 foot diameter steel vessel as it would be on the ship. Electric Boat was selected to build a Nautilus and to do those full-scale mock-ups. But they were going to design the submarine and the land-based prototype reactor at the same time. He went up to Portsmouth Naval Shipyard and talked to them. He wanted to assign them the Seawolf. And they were busy building the post-World War II diesel submarines and said they didn't have time or ability to do that. So Rickover was blunt, as I said. He went into the commanding officer of Portsmouth Naval Shipyard's office, picked up the phone, called up the president of Electric Boat and said, I'll be down there in 3 hours and you're going to build a Seawolf as well. Thank you, goodbye, clunk. And he left. He was sort of brusque. Coffee is here. Anybody wants coffee? 1950, CNO, the Chief of Naval Operations, Bureau of Ships, and the Atomic Energy Commission approve a 1955 launch date for the Nautilus, and they'd never built a reactor before. And Rickover liked that. Give me a date, and I'll just beat the hell out of everybody until they perform the duties required to get there. 52 hafnium is selected for the control rods. Hafnium is an impurity in zirconium ore, and it highly absorbs neutrons. So if you're going to use zirconium for the fuel rod cladding, you have to get the hafnium out of it. And they said, oh, cool, we'll make the control rods out of that. On my 16th birthday, the Nautilus S1W, the shipboard, our submarine first design Westinghouse S1W, went critical in Arco, Idaho. And that's really incredible. They've got this reactor. Nobody ever built one before. Nobody had built the pressure vessel. Nobody had done any of the stuff, but they took that thing critical in 1953. And only 3 months later, they operated the S1W reactor at 100% power for 100 hours, complete straight through. And that simulated a crossing of the Atlantic by a submarine. So it was a big bragging milestone. Nautilus was commissioned in 54, went to sea 55 to 1980. 54 shipping port commercial power plant was assigned to Rickover, and we'll talk about that in the civilian reactor course in a couple of weeks. But they assigned it to Rickover basically because they were sure he would make it happen. This is the S1W prototype in Idaho. It's built in a submarine hull cylinder, the same diameter as would be the Nautilus. So as they started to figure out how to build this reactor, they also had to figure out how to cram it in a very limited space. I have not been to Idaho. You've been to Idaho, haven't you, Will? Somebody back there has. Don, did you go to one of the prototypes? Which one, A1W? Was it in a little round tube like that? So Don McLaughlin, a nuclear engineer, and then he became Dean of the Arts at the University of Florida. I don't know how that works, but it worked okay for Don and the rest of us. Okay, now this is the Nautilus, and just take a look at that. Electric Boat knew how to build submarines, and everything from this thing we call the sail with the periscopes and masts, everything forward, they had been building those for 15 years or more. So that was no problem. Everything after the sail, this is the reactor compartment, auxiliary spaces, engineering spaces, all of that was all brand new, and nobody had ever done anything like that before. So the Nautilus and the prototype were authorized, fast-tracked. Building the submarine itself was no problem. Designing and engineering a totally new technology was. One of the questions early on, would there be enough U-235 to make the fuel rods? And what enrichment percentage did it need to be? Remember, we first had the first demonstration bomb was plutonium, and then they dropped the U-235 bomb over Hiroshima, but they couldn't test it earlier. They didn't have enough U-235 in 45 to waste a test with U-235. The fuel element construction, nobody had ever done anything like that before. You need to put some uranium in a very thin tube clad with zirconium, and you had to run hot water by it. The reactor plant on my submarines was running at an average of 480 degrees in the reactor. So nobody had done that before. So they had to design all of this stuff simultaneously. The pressure vessel design is probably some 9 inches or more stainless steel, and they had to build it and bolt it all together. And they hadn't done that before. The control rod drive mechanisms, very important to shut down the reactor, but they had to be fail-safe up to 45 degrees because submarines will run around the ocean and do angles and dangles, and if you make a hard left turn, the ship will rotate a little. And when we went out with midshipmen in the submarine in the summertime, we like to do angles and dangles, so we'd be at about 300 or 400 feet, going ahead full, put all the dive control surfaces in full dive and make a really steep dive down to test depth and bop back up. And lucky for me, we always bopped back up. New materials refinement. They had to figure out how to find it, get the ore separated, make the metal cladding that they need, weld it together. It was amazing. They had to design a steam generator. They're going to pump this 480-degree water through some U-tubes in a steam generator that had never been designed before. The primary coolant pumps and valves. There was a requirement by Rickover that there could be no leakage. And the manufacturers of the pumps would come back and say, well, how many drops per minute is that? No leakage. It was like a George H.W. Bush moment. Read my lips, no leakage. And that included all of the piping that was bolted together to take this very high pressure, high temperature water in and out of a steam generator and make steam. So the steam plant was in a confined atmosphere of a submarine. I don't know if you've ever been in a steam plant, but if you ever walk around anywhere where there's steam, you'll see a little wisp of steam coming out. You can't have that in the submarine. No leakage. Extremely limited underway maintenance requirements. The reactor compartment was basically sealed and shut when we went to sea, and you couldn't go in there unless you shut the reactor down and let it cool down. And very few times anyone ever did that underway. Safety and reliability of paramount concern. And we'll talk about that more next week when we, somewhere along the way, when we talk about nuclear disasters. The United States Navy nuclear power program has had 0 nuclear accidents ever. The reactor compartment had to be shielded to keep the neutrons and the gamma rays and everything away from the crew. And they had to design all of that. Nobody had ever had to do that before. And the personnel radiation exposure was monitoring. He'd like to say, and I don't know if we ever quite got there, that submarine or nuclear powered ship service, the people who are operating the reactors would never have more radiation exposure than the civilian would be walking around the streets of Denver. We wore personnel badges, and we had little dosimeters that were shaped like a pencil in our pocket, and you could read that and hold it up and see what you were doing. But the film badges were developed on board, and they had to keep a track of everyone's total exposure, and that record went with you wherever you went. This is the USS Nautilus 571. I was able to tour the Nautilus probably in 1963. In the summer, I drove over from Cornell to Groton, Connecticut, and I was able to walk through a number of the submarines. This is the second submarine. The Seawolf was designed, the reactor was designed by General Electric. It was a liquid sodium cooled reactor. There are several bad ideas associated with doing that, but in the beginning, they didn't really know what was going to work. So it was, again, let's try out everything and pick the one that works the best. And they replaced that reactor later. In the lower right-hand corner,
Big SSN 575 on Seawolf's conning tower. The second boat to log it out, underway on nuclear power. The back aft nukes have quite a job, just torquing on the screw. Between steam leaks and reactor scrams, they haven't much to do. She may be old, but she's still bold at the helm, Captain Charles McLean. No finer ship, but fine.
My friend went from being XO of the newest nuclear submarine in the Navy to being commanding officer of the oldest nuclear ship in the Navy. But Seawolf was taken out of service for 2 or 3 years, cut a hole in it, stretched it out, put a whole bunch of secret stuff in there. And when Charlie reported aboard in Mare Island, one of the civilians took him through a building and he showed him a whole bunch of stuff. He said, "This is what's in your extra section." And Charlie said, "What does it do?" He said, "I can't tell you." But he does talk about it in his book. He doesn't 100% say that he did it, but there was a guy in the spook community, the intelligence community, who had been on the Mississippi River, and he saw a sign that said "No anchoring, cable crossing," and he thought, "I wonder if the Russians do that in the Sea of Okhotsk between Vladivostok and the mainland." And so they sent a submarine in there, and there in Russian was a great big sign that said "No anchoring undersea cables." And so the Seawolf was designed and equipped with special stuff. And Charlie took the Seawolf up in the Sea of Okhotsk, and they went down to the bottom, and guys went out from the submarine, and they put stuff on that cable. So they were able to read all of the messages from the commander of the Russian Navy in the Pacific to Moscow for a number of years before the Russians figured it out. And Charlie is the only nuclear submarine commander that I know of that has 2 distinguished service medals. That's the one below the Medal of Honor. And a Legion of Merit, which is the one below the distinguished, and a bunch of others that he got. It was the kind of a trip that they would go out. They couldn't tell anybody what they did, and he would come back, and they flew him out to Pearl Harbor, and the admiral took him into a little room with just Charlie and the admiral and said, "Here," and pinned a medal on him. And Charlie said, "Wonder what that is." When I was XO of Tenosa, we did some operations in the Mediterranean, and we got a few medals as well. And the admiral in the Pentagon who gave me my medal said, "I know what these guys did, but I can't tell you, but here's his medal." Mine is way down below any of the ones Charlie got. Okay, diesel submarines have a limited submerged capability. Battery capacity is limited. Each battery has got cells. Each cell is about 3 or more feet square and about 5 feet high, and weighs a couple of 1,000 pounds. And you put 126 of them together and wire them up right, you get a 250 volts DC. And the diesel subs had 2 batteries. And on my submarine, we could put them in series to have 1,000 volts to drive the electric motors, or put them in parallel to have 250 volts. But diesel boats can go, we had a half-hour rate. That's if you ran the ship at full everything you could do for a half an hour and didn't deplete the battery completely, you could go maybe 9 knots for a half an hour. So you could only get like 4 or 5 miles away from whatever you were trying to escape from. So on the surface, we could go about 15, 18 knots. Submerged, we could go about 15, 18 knots on the snorkel. All nuclear submarines still have a diesel engine. And if your diesel engine is non-operable, so is the entire boat. You must have a secondary means besides the battery of starting up the reactor again. When we were stationed in Mediterranean on the cruise I was talking about, we wiped the blower for the diesel, which is the thing that compresses it. And diesel cars have the same kind of a little turbo to increase the pressure of the air and fuel going into the diesel. We wiped the blower, so we couldn't run the thing. We had to be alongside the tender until we were able to repair the diesel engine. Okay, they're vulnerable on the surface at periscope depth or when snorkeling. And so really a diesel submarine, they're submersible surface ships, really. And during the war, the Germans didn't have a snorkel until the end of the war. And their plan was to be on the surface at night when they were less likely to be detected, charge the batteries up and race around to try to get ahead of a convoy and get in position, submerge, and fire torpedoes. So really, submersible submarine ships, submersible surface ships. Okay, here was the Threadfin. I spent 2 months on the Threadfin in Key West, little guns on a little ship, but that was as it left for World War II. It went under a conversion called a Guppy, Greater Underwater Propulsion Power, and they took off everything up on the deck. They put a fair water around all of the masts. The bridge is located here where the officer of the deck is on the surface, and it's fairly sleek. So I spent 2 months on board that submarine. This was my submarine, the USS Trout. You've probably seen me wearing this hat because I wear it all the time. And it says USS Trout, SS 566. And in the middle of that emblem are the gold dolphins for an officer qualified in submarines. And I was on board for only a year, and I was ass up and head down in all the bilges and everywhere, tracing all the pipes and the electrical valves and electrical power and distribution. I had to learn everything on that ship. And at one time, I could crank up that diesel engine. Only one time. They didn't let me near it anymore. Okay, the Albacore, I'm going to go through a few of the submarine designs just to show you the change in this. This is a teardrop design. Now, the Albacore was not an attack boat. It didn't have any torpedo tubes. It was designed simply to test teardrop design, ship control at high speed. And one of my skippers had served on the Albacore out of Portsmouth, New Hampshire. They would go out and they would run a speed trial to see how fast they could go. And they could get up to about 33 knots. They would come back in, put it in dry dock, and simonize it. So they must have bought simonized by the ton. And then they would go out and see if that made it go faster. These are the last class of diesel submarines, were of the teardrop design. But Rickover did not want diesel submarines that could do some of the things that nuclear submarines could do, because that was in competition for the dollars. So after a few of these, they didn't do it anymore. This is the Triton. I was able to walk through the Triton that same summer when I went over to New London. And the skipper at the time was Captain Ned Beach, World War II fame, and I saw him sitting in his cabin doing something or other. But it was a radar picket submarine, and you can see the big half moon or quarter moon shape hole in the sail where they could raise and lower the mast back when they were having destroyers doing submarine picket design and looking for Russian bombers coming over the horizon. That was why this one was built. Then Ned Beach took it around the world, submerged mostly, and that was the first time that had been done. It's the only ship with 2 reactors, only submarine. So these are a whole bunch of them. These are just incremental design changes. I was out on a skipjack class at the very top out of San Diego. On the surface, we were going to go up to San Francisco, and the officer of the deck told me, we can get up on the step like a motorboat. When you really get it up on the step, you can go faster. And I said, nah. So he called down and told him to put the stern planes on 10 degrees dive, which dug the stern in and let the propeller get a better churn on the water. And we actually kind of floated up and came up on the step, and we're doing about a knot faster. So Tullabee was electric drive. Thresher, we'll talk about the Thresher on the last discussion, but the Thresher was the first of the class of the submarine that I was XO of. And it was a new design. We had the newest sonar, big spherical sonar, so you could really search all around. It was really excellent. Tullabee was a little submarine. It was the only submarine that they put the combustion engineering reactor in, but it was electric drive. George Washington was the first Polaris submarine. It was actually the first keel laid down for skipjack. They cut it in half, pulled it about 180 feet apart, and put in the missile compartment. The missile compartment was rated at 1,300 feet, and the rest of the ship was at 700 feet, rating for crush depth. The Jack was another submarine. It had contra-rotating direct drive, so it had a slow-speed turbine, no reduction gears, and it really didn't work out, and they didn't build any more after that. So we have improved submarine classes. Mine was a Lafayette class submarine, 16 missiles. I asked the squadron weapons officer, what would you like me to do for you while I'm out at sea for 2 months? He said, bring them all back. Okay, then the other guys are just various improvements along the way. And the Los Angeles, the 688 class, was the real follow-along after the Thresher class, which became the Permit class after the Thresher was lost. They were longer, bigger, stronger, faster. And I toured an SS in 688 class submarine. And when I went down in the engineering spaces, I looked, and they had this great big condensate pump. And that was one of our main pumps. And they didn't use any of our little pumps because they were 30,000 shaft horsepower. We were 15. Then there's some other stuffs going along. And the newest Seawolf lead ship of 3, with the Jimmy Carter being the last, he was one of the few living people who had a ship named after them, including Rickover. There's a submarine named Rickover. Okay, I have to tell you about this. And the reason I have to tell you, this is NR1. It was a nuclear-powered deep diving research submarine, because Bud Ames, all of us remember Bud Ames. Bud Ames was a submarine designer, and we used to tell people he designed them and I drove them through the ocean. Well, he was designer of some parts of this project for the NR1, and he was required to brief Rickover about it. And the guy before him had a slide up with little words. That's why I try to use big words. The guy with little words got hell from Rickover because he couldn't read the slide. And Bud's slides had big words on them, and he put it up and he started to talk about it, and Rickover said, shut up, I've already read all of that. So you couldn't win. So it was 140 feet long. It's the only submarine that I know of with wheels down here. They have an access below, so an aquanaut could get out the bottom. This is a remote retrieving arm. And here are the thrusters that could control the submarine here on the bow forward and below, and then on the stern forward and below. I operated with the NR1 one time when we were out of New London. They always required someone to be in complete and continuous communications with the NR1 while they were operating. So we were at about 200 feet, and they were down on the bottom of the Long Island Sound doing something. And so we had to check with them every hour or two. Everything okay? Okay. Then we would send in a message back to the squadron. They're still doing fine, but it could go to 2,300 feet. It's done a number of interesting things. It recovered a hydrogen bomb off the coast of Spain inside the Med that an Air Force plane accidentally dropped. That was all considered bad form, to drop your nuclear weapons. Okay, this is the Parche. Charlie was XO of the Parche. And I'm surprised that you can find this on the internet, because if you look down here, there's access for divers to get out and do stuff. They have replaceable midsections with different kinds of intelligence packages that they can put in. They have skids instead of wheels, so they can rest on the bottom. Resting on the bottom is pretty tricky with the nuclear submarine because our seawater inlets were on the bottom. And if you get on the muddy bottom and you're resting there, your reactor is likely to shut down. So they had other stuff. This along the side here and going out by the tail is a towed array sonar. My ship didn't have one when I was serving on it, but that was a fantastic improvement. Submarines, and you can see the circular or spherical sonar up in the bow, but there's a noisy thing behind the bow, so submarines can't hear what's behind them, so they periodically have to change directions to listen behind them. With the towed array, that was a much improved situation. And there was also, they don't show it here, but the Polaris submarines had a towed wire antenna that we streamed out, about 2,000 feet of it, about as big as, I'm sorry about that, about as big as my middle finger. And it trailed out behind us and floated on the surface, and we could receive radio messages that way. The captain and I one day were having right full rudder, left full rudder arguments in a very rough sea. And of course, since I'm the junior officer, it was my fault. I cut the wire. And the radioman gave me a little piece of wire about that long on a plaque that said, "To Lieutenant Commander Wynn, without whom we could not have made this possible." And so they had to find another 2,000 feet of wire and stream it out behind us. Okay, where are we here? This is the buildup of the fleet. If you look here on the left, 52, the Nautilus and Seawolf are under construction. Then they start really building up. And at one time, they had as many as nearly 35 or 6 submarines and surface ships under construction at one time. That's why Rickover would occasionally send his people over to the Bureau of Naval Personnel and go through all the surface records of everybody that's not a nuke and see if you can find some new ones for me. The Burke Scholars had a little old lady, we called her our den mother. She would always draw out our service records and stick them in her drawer and lock it. Because she really wanted us to finish our PhDs, which were typically 4-year programs. But they were jerking people out of Naval Postgraduate School to come and be nukes. And one of the navigators on one of my submarines was in that unlucky group. He was working on getting a master's in something. He was issued an invitation which he couldn't return down, and he became a nuke. This is just a listing of the surface ships and the aircraft carriers that have been built and are being built and in still operation. And then the nuclear ship Savannah was a civilian ship, and it was manned by civilians, and it was a transport ship, and it was to be part of the Atoms for Peace program and go around the world and show the flag and how safe nuclear submarines are, or nuclear power plants are. So let me just back up one time. Up here, the top aircraft carrier is the Enterprise. It was the first ship with 8 reactors. It had 8 reactors. One of my instructors at Prototype said, "I have the honor and privilege of having scrammed all 8 reactors at once." So, but later they're down to one or two nuclear power plants on the new surface ships and the aircraft carriers. Basically, we're only doing aircraft carriers and submarines. The rest are not cost effective in terms of how much it costs to build them. Okay, so this is a trick question. There's the Enterprise, I think the Galveston and the Dahlgren, D1G was Dahlgren, a destroyer, but they later changed it to a cruiser because it was so big. The submarine that I was on, the Polaris submarine, was 425 feet long with an 8,000-ton displacement, which was the size of a light cruiser in World War II. So the trick question, how many nuclear submarines are in this picture? Nobody knows, nobody ever knew. There may be some, there may not be any, there could be half a dozen, you would never know. And the people on those ships would also never know unless they talked to each other on the underwater telephone. Okay, there are only two kinds of ships, submarines and targets. Okay, Charlie was Charlie McVeigh, the Seawolf skipper, and Bing was his PhD advisor, and Bing sat in an office right outside where I would go in to work on my reactor, and so I interacted with him quite a bit. And Rickover's words, so they're not all Rickovers, they're not all Bings, they're not all Charlies, but they applied. So work hard and maintain high standards. Don't listen to the first answer, it may not be right. Drill down, get the truth. A good eye doesn't automatically happen. You have to nurse it through and keep working on it, the kind of work that makes your head spin. That was SSN, by the way, stands for submarine nuclear, but all the guys that were on the SSN said it stood for Saturdays, Sundays, and nights. So don't give up on yourself when you're out of gas. If you think you have a good idea, don't ask your mother. Ask some hard-nosed SOB who will tell you what they really think. Be sensitive to the people around you. That didn't apparently apply to Rickover. He didn't care about the people around him as long as they did hard work and good work and produce results. If you're not anxious about or scared of your next job, you're either brain dead or overqualified. Next week, we're going to talk about the Army, Air Force nuclear power programs, NASA, Atomic Energy Commission, China, Russia, space nuclear power programs. So, let's see, how did we do? Oh, we have good time. We have time for sea stories and to tell you how nuclear and diesel submarines operate. So, first of all, I will show you, and sorry about the Zoomers. This is a set of the gold dolphins that you have to earn. You can't just be assigned to a submarine and after a little while they give you these. You better know how to operate everything on the submarine. Okay, what does it mean to be on a diesel submarine? Like I said, they're submersible surface ships. It was a lot of fun for me. I really enjoyed driving the submarine on the surface. And as a lowly ensign, the junior officer in all of submarine Atlantic fleet, I was able to drive the submarine in and out of Charleston in a pretty tricky river. So being on the nuclear submarine is different because you go underwater and it's like sitting in this room. I mean, it's rock steady. Unless you're in the middle of a couple of hurricanes, then you go down to 200 feet or more. But on the Polaris submarines, we normally ran at 4 knots and 120 feet. And then if it got rough, we'd go down a little lower. But we needed to be around 120 feet so that floating wire antenna would pick up our signals to tell us to blow up Russia. Luckily, we never got the signals, but we were ready. Um, no, that's okay. So being on a diesel boat, you were in port sometimes, but what was fun at night on the way to the med, I was junior officer. I was the officer of the deck and the midwatch, midnight to 4 o'clock in the morning, because the other senior officers wanted to sleep. So it was really cool to be driving along in the middle of the ocean and see all the stars and not see anything else anywhere. And I always picked a star that which way I was heading, and I could see, because they're always testing the junior officer to see if he's alert. And if the star moved over, I knew that they were doing something down below, and I would call down and say, "Mark your head," and he would, which tells the helmsman to say which way he's pointed. And then he would, "Oh, 030, sir, sorry." And they would come back to course. Nuclear submarines, we went out on the Polaris submarine. It was a 3-month cycle. So we lived in Charleston at the time, but the submarine was out of the Holy Lock. So we would fly to the Holy Lock, and there would be 2 crews there, and we would relieve the gold crew, and they would fly back after about a week. Then we would fix all the things that they broke, and then we would go out and test everything at sea for a few days, come back in and fix the last minute things. And in Holy Loch, Scotland, if there was ever a sunny day, it was all hands on deck, chip paint. We're going to paint the ship finally. And then it would rain again. But the Holy Loch was an interesting place. I like to walk around in downtown Dunoon, and I walked by this beautiful lawn in front of a little house, and a man was out there snipping the grass with clippers. And I said, "How do you get a lawn look so beautiful like that?" He said, "Well, you started about 150 years ago." The other thing we found out in Dunoon, you cannot go to a pub and sample all of the scotch, because you'll lose track and start over again, and it doesn't work. So we would then go out for 2 months, and our operating order every time, paragraph 1, remain undetected. And so we would go out and go up between Ireland and Scotland and go up in the North Atlantic. And typically, if you've been in the North Atlantic above the Arctic Circle, you're inducted into the Navy's Blue Nose Society. We didn't do that because where we were was top secret. And let's see, what else was it? Oh, so we're 2 months underway underwater. We went on 6-hour shifts. So if you had 18-hour days rotating around, and you would stand watch for 6 hours, you'd have 12 hours off, and you'd just repeat. And most of the time we were just going along 4 knots, trying not to make any noise, not get detected. And then when the navigator said, "I need to get a star sight or a transit satellite pass to get a good fix," because we needed to know where we were. We knew where Moscow was, but we needed to know where we were if we were going to blow up Moscow. And the joke was, when we came back from a patrol, one of the patrol crews was told, "Because of your very poor performance on the last patrol, your target package for the next thing is orphanages and churches." I didn't know where our targets were, but you can make a guess. If on the target tape it said MSCK, that sort of sounds like Moscow, but you never knew. So we were out for 2 months, driving around, remaining undetected, and we were given our own perfect square of the ocean. Nobody else was allowed to be in it while we were there. And on the Tenosa, when we went to the Med, we were told where the Polaris submarines would be, and told us, in such and such an area, do not come above 300 feet. to let the Polaris submarines have the 120-foot depth. That was at the time of the John Walker spy incidents, and the Russians knew exactly where all of the assigned operating areas were. And when we got up to periscope depth at one time, we needed to send a message to the squadron commander. And as soon as we started tuning up our radio, there was a much more powerful radio down in Egypt on the same frequency jamming our signal. So they knew what frequency we wanted to operate. They knew where we were, but we never saw or heard any of their submarines. Later, when I was in the Med, we did some interesting things. And at one point, we had a U.S. submarine in automatic tracking on one of our sonars and a different submarine in automatic tracking on the other sonar. And we were watching both of them do whatever they were doing. And one night, the captain said, "XO to the con." And I was eating dinner. And I didn't go fast enough. He said, "XO to the con." So I went up there to look through the periscope. He wanted me to confirm his identity of the Russian submarine that we could see through the periscope. So that's as much as I can say about that one. But Charlie says a lot more in his book. I have it here if someone wants to borrow it. I do want it back. You won't believe the things that Charlie can tell you he did. I just wish I had a commanding officer like Charlie McVeigh when I was doing my service. He was a fantastic leader of men. I went to his change of command, and one of his enlisted men came up to me, maybe had a little too much to drink, put his arm around me and said, "I'd follow that SOB through hell and back." So he had a great respect of his crew members. We all had our jobs to do, but we could do other jobs, but you had to trust each other. And we had the ability on nuclear submarines to surface people. If a guy didn't want to go to sea with us, we put him on a surface ship. He's gone out of there. So, and that happened rarely. Okay, I guess it's time for questions. I've blabbled enough.
All right. I don't see any on Zoom yet. Any questions out here? Let me make my way over there. Hold on.
Walter, I just want to tell you that in late 1955 in Roanoke, Virginia, I was the manager over a little group that was making control rods and control panels. So they put specs on those things were out of sight, but
no leakage.
We did it, yeah.
Was that Babcock and Wilcox?
Excuse me?
Was it Babcock and Wilcox in Lynchburg?
I was GE.
Oh, GE. Okay. Excuse me.
And then Mr. Brickhow just asked, what is the longest, what was it, a nuclear sub can stay at sea?
You can stay at sea until you run out of food. That's really the limiting situation for us. We always took extra food in the number 10 cans, the big ones about like that, laid them down on the deck, put plywood over the top of them, and when you got rid of all your fresh vegetables, you could start opening cans. And we did in some of the submarines, they have an escape tunnel to escape the submarine. And we would take cabbage and put it up in the escape tunnel and bleed in nitrogen so that they wouldn't rot. At least they would last a little longer. And onions. But basically, the current reactors need to be refueled either 15 years or the newest one 60 years. They've designed the fuel and the whole system so it does not need refueling. I've been in 2 different refueling overhauls when the refueling cycle was like 2 years or 3 years. And that's a really tough overhaul. Yes, sir.
In the Jacksonville area, around Fernandina Beach, was there a submarine base there? Because at one time I saw 2 submarines just out in that big bay there.
I saw one there too one time. I took my motorhome and my mother. My grandfather had a place on the beach years ago at Fernandina, and we went over to Fernandina Beach, and we camped at Fort Clinch, and I saw a periscope going by, so I climbed up on top of the motorhome so I could see what it was, and it was a Trident submarine. Their base was in Kings Bay, Georgia.
Okay.
So it was come in through the river at Fernandina, make a hard right, and then wind your way through these coastal non-flowing rivers to get up to the base at Kings Bay.
The other question I had was, where does Red October fit into your stories?
Red October is a fabulous book, and it came out before Blind Man's Bluff, which is also an excellent book to read about submarine operations in the Cold War. And Red October had a lot of interesting stuff that was better than I thought they should have been putting out. So, but it's a little crazy in terms of how far it went on capturing the crew and everything. But they did have a propulsion system called the Caterpillar. And that was an electromagnetic hydrodynamic, big magnets, DC current, and it became an electromagnetic pump, and it was no moving parts, very quiet. I can say, and nobody can dispute it, I invented that when I was a senior at the Naval Academy, and I was talking to my professor about it, and he said, oh yeah, we could set up some experiments and work on that, but we never did. And I wrote about that in my command thesis in order to get command of nuclear submarines, and I gave it to my CO, and he went apoplectic. The old man will die if he ever sees this. Don't ever show it to anybody. So it never went anywhere. But it would work in salt water.
Thank you. Izzy, go ahead if you'll unmute.
Yeah, I have an anecdote. In about 1980, when the Navy consolidated all Navy training under one headquarters, one of the things that was done was to put nuclear training, pre-reactor nuclear training in Orlando. And Rickover was very angry about that because he thought that his students in Orlando would be distracted by everything in Orlando, and whereas if they were up in Idaho, there wasn't anything to do but study.
I'm sure that's true. Yeah, my reactor prototype was in West Milton, New York, and it was actually in the great big steel ball that was built as the containment structure for the Seawolf's liquid metal reactor. And so we had to go in and out of this pressure-controlled great big steel ball every day to do our work on the D1G prototype.
Yeah, Walter, so when you were talking about the Red October, I was thinking of that scene at the end where, they're coming up the river, in the submarine. So I was just curious what you need in the way of, I don't know if the correct term is draft, but what's your minimum depth that you need to be in, when you're coming up, say, like a river?
You really like to have 10 feet under the keel, because as you go along in a narrow waterway, you tend to sink down a little bit. And the rudder is the lowest thing on the ship. And so you need to have you'd like to have 10 feet below it. So the nukes that I was on had about 32-foot draft. So you'd like 40 feet of water or more under the keel. A lot of dredging went on for the Kings Bay nuclear submarine. They drew more water than I did, and it's very tricky water. And we came in, typically we'd come in and a tug would come alongside to assist us. Single screw, you can't do the same jockeying around you can with twin screws. And when I was coming in to make a landing in part of qualification for command in New London alongside the tender, and there was another submarine and then the tender, and then we were supposed to berth outboard. And I came in at an angle, and the tugs really weren't able. There's quite a bit of current there sometimes. Tug weren't really able, and we touched this other submarine, and the other skipper I'd known from my time on the Trout, Jack Helliwell, came running up to see what I had done to his submarine. And the problem he was concerned about, our torpedo tubes were amidships instead of in the bow. When you put that spherical sonar up there, you don't want torpedo tubes up right near that sonar. So later when we went in dry dock, the captain looked at that little indentation in the sonar dome and said, "Wonder how that happened." I said, "I believe I did it." Anybody else?
I think I saw Elliot Simon. Did you have a question?
Yes. Yes. Hi. Thank you for a terrific presentation. Really enjoyed it.
He's on Zoom,
Very
Walter.
Oh,
And,
that's why I can't see him.
I was wondering, were you aware during your time with Rickover of any anti-Semitism towards Rickover? Because there weren't very many Jews at the top level of the military at that time, or at any time.
There was a lot of anti-Rickover, but I don't believe it was anti-Semitism. When he made captain, he was still a captain in 1952, there was up or out requirement. And if you did not make the next advancement, you had to leave the Navy. And he was due for promotion to Rear Admiral. And none of the Navy people wanted him to be a Rear Admiral until Congress refused to review the proposed listing of admirals for that selection and sent it back for correction. And that's when Admiral Rickover went from a Navy captain to a Rear Admiral. He ended up as a full 4-star admiral, and he served in the Navy for something like 63 years before I think it was Reagan decided to have a retirement party for him. So now the director of naval reactors is a 4-star admiral who's supposed to commit to spend 8 years. 3? I thought it was more than that. Yeah, but they're supposed to spend quite a few hours, quite a few years in that job, and it does not count against the other Navy admiral slots. It's like an extra slot for that admiral. So when Rickover was retiring, Kenny McKee went to replace him, and he reported in Charlie's book, you'll see it. And when McKee reported in to says, "Admiral Rickover, I'm here to replace you, sir." He said, "Get out." And so he left, and he came back a few days later, and he said, "Get out." And he says, "Come back Saturday morning at 9:00. So he came in Saturday morning at 9:00. Rickover's got a few cardboard boxes with stuff that he wanted to take with him and said, "I'm never going to talk to you again. Don't send me a letter. Don't call me. I'll never call you. You're in charge. Goodbye." And so it was really a testament to how Rickover felt about the people he had trained. He could just leave them in charge and everything would be fine. I don't know if I answered your question, Elliot. Sorry.
That's okay. No, that was fine. Thank you.
All right. I don't see any other questions, but another outstanding presentation, Walter. Thank you.
You're very welcome.
And next week, you want to give us a preview for next week?
It's on the slide there. Next week is the U.S. Army Nuclear Power Program, Air Force Nuclear Power Program, atomic energy programs in space and NASA nuclear power programs, and Russian satellites with reactors and that sort of a stuff. Bring your pillow.
Thank you, everyone.